moving on with multiplication, what happens if you have multiple numbers? Well, if you have an even number of negative signs, the 2 or 4 or 6 negative signs cancel each other out. And so if you have an even number of negative signs, then your answer is going to be positive. If you have an odd number of negative signs, then your answer is going to be negative. So for example, we've got 3 numbers we're multiplying right over here. We're going to go left to right. So negative 3 times 2 gives us negative 6. Now we've got negative 6 times negative 7, and that gives us 42. And if we take a look at it, we had 1, 2 negative signs in our question, so an even number of negative signs, which explains why we ended up with a positive result here. Okay, so next one, we've got negative 4 times negative 5. First, let's do that to get positive 20. So this gives us positive 20 times negative 6, which gives us negative 120. So here we had 1, 2, 3 negative signs, an odd number, which explains why we ended up with an odd number in our result. Okay, and last one, this one's a little bit interesting. We've got a negative sign out in front of the brackets. The way to think about that is that's really a negative 1 out there. So there's a negative 1 times a 2 times a negative 3. So we're going to deal with these two first to get negative 2. So we've got negative 2 times negative 3, and that gives us positive 6. Okay, sometimes you get questions where they've given you a whole whack of negative signs. So here, again, we've got just a negative. You can think of these as negative 1s. So we've got negative 1 times negative 1 times negative 1 times negative 4. And so we've got 1, 2, 3, 4 negative signs, which is even, which means our answer is positive at positive 4. So take a minute and see if you can do this challenge one here. And let's do this one together. So how many negative signs do we have? 1, 2, 3, 4, 5, 6, 7. So an odd number, which means our answer is going to be negative. So we end up with negative 13. Another way you could think of it is this negative 1 times negative 1 cancel each other out to make positive 1. Same thing with that pair, and same thing with that pair. So you're left with just negative 13 there. Okay, another thing that's important to be careful of is thinking about powers. So if you've got negative 5 squared here, we know exponents mean we take whatever is, in this case, whatever's in the bracket that's being squared, and we're going to multiply it by the number in the exponent. So here we've got negative 5. We multiply it by itself so that there's a total of 2 of those numbers. So negative 5 times itself times negative 5, and we get positive 25. Okay, so all good, right? We've got negative 5. So the way I say this is negative 5 all squared, because the negative 5 is being squared. That gives us the negative 5 times negative 5, which explains why we get positive 25. Compare that to this one over here. Here you have negative and then 5 squared. Because there's no brackets, that square, that exponent, only applies to the thing immediately to the left of it, to the number immediately to the left of it. So the squared part is only pertaining to the 5 there. So you could think of that as the negative 1. There's a negative 1 out front. That's what made that 5 negative, okay, multiplied by 5 squared. And so you get negative 1 times 5 squared, which is 5 times 5. And so you end up with negative 25 in this case. Okay, so the brackets make a difference. So let's do some examples. So we've got negative 3 all squared. So that means negative 3 multiplied by itself. So negative 3 times negative 3. And so here you're going to get positive 9. Next one, we've got negative 2 to the power of 4. So that's negative 2 times negative 2 times negative 2 times negative 2. We'll go left to right. So negative 2 times negative 2 gives us 4. Okay, and then here, multiplication is actually associative. We don't have to do this left to right, but we will. Here we get negative 8 times negative 2, which gives us positive 16. Okay, negative 2 to the 4. How is that different? Well, this time there's no brackets, which means that exponent is only applying to the 2. So you can think of this as there's a -1 out front to make that negative sign. And then we're doing 2 multiplied by itself 4 times. And so here what you'll find, so I'm going to leave the -1 out front and then just do these. 2 times 2 times 2 times 2 gives us 16. And so we end up with an answer of -16. 2 to the power of 4 is 16. So negative 2 to the power of 4 gives us -16. There's no brackets there. Okay, how about this last one? Go ahead and try this one on your own. And let's compare our answer. So we've got a negative that is not in brackets, so it's out front. It's like a -1. And then we've got a 3 squared, which is 3 times 3. And so here you'll end up then with -9. Okay, let's take a look at some word problems. So we've got a manager who's doing a work productivity study. The manager finds that the average worker begins 10 minutes after the shift begins, leaves for lunch 5 minutes early, and returns 10 minutes late. So the manager is losing some time from these employees. But the average employee also works 15 minutes after the shift is over. And employees spend an average of 22 minutes engaged on their 15-minute coffee break. So they're overextending their coffee break a little bit. Okay, so if the plant employs 230 people, how much productivity is lost each day? Okay, so if we think about per person, or I guess per employee, how much time is lost? Well, they're beginning 10 minutes after the shift begins, so we're losing 10 minutes. So we're going to say -10. Okay, and then they leave for lunch 5 minutes early, so we're losing another 5 minutes, so plus -5 then. They're returning 10 minutes late, so that's another -10. But they're working 15 minutes after the shift is over, so we're gaining 15 minutes from them. And they're spending 22 minutes on the 15-minute coffee break. So you can think of that in 2 ways. You can say, well, that means we're losing 7 minutes, or you can think of it as we have 15 minutes minus 22, which will give us -7. Okay, and if we add all this up together, and I encourage you to do this with a calculator, you'll find you get -17. So per person, we're losing 17 minutes per day. So if the plant employs 230 people, it's going to be 230 multiplied by that -17. And that will give you -3,910 minutes. So the plant is losing -3,910 minutes per day, which is a lot of time. However, I think I would encourage that manager to also think about the happiness of their employees. Sometimes losing a little bit of time is good if your employees get to talk to each other and enjoy their work. Okay, next one. The high temperature one year for a Midwestern town was 88 degrees. During the winter, the temperature dipped as low as -14. We want to know the range experienced by the town that year. So the range means like how many degrees is there between the high and the low. So what we're going to do is we're going to take the high temperature and we're going to subtract the low temperature. So 88 minus the low, which is -14. Okay, so you get 88 plus 14, and that gives us 102. So the range was 102 degrees Fahrenheit. And if you think about it on a thermometer, that might make sense. If you started at 88 degrees Fahrenheit on a thermometer, went all the way down to 0, now that's 88 degrees, but you've got to go another 14 degrees to get down to -14. So you would end up with a range of the 88 plus another 14.